here will be the basic DC chopper, which is the basic for all the DC-DC converter that we are going to go through after this. Okay. Okay, so basic DC chopper. So this is a circuit of a DC chopper. So you have a input side of input voltage and also the output voltage. So we are going to control the output voltage over here using the switch. Okay, so when we are talking about this switch in a DC-DC converter, uh, it is not the usual switch that we use in a circuit or the switch that we use to turn off or turn on the light. It's not the same switch. Okay, so this switch, okay, is known as power electronic switch. For example, we use MOSFET, IGBTs, NCTs, power BJTs, and GTOs. Okay, so this switch is known as power electronic switch, which is this is the example. Okay, so the difference between this switch and the conventional switch is that we can control the on and off of this switch to achieve certain frequency. Okay, meaning that the on and off of this switch will be very rapid compared to what we can do analog with the conventional switch. Okay, so usually there will be another circuit or that is connected to this switch that will control the on and off or open or close of this switch over here. Okay, this is possible because we are using this MOSFET, IGBT, and so on as the switch. Okay, so here let's go to an example to explain to you what is a DC chopper. Okay, so let's say we have a load which needs 5 volt, but we have a power supply of 10 volt. Okay, so how do we get the 5 volt at the output? Okay, so let's just assume that the current is 1 ampere. Okay. Okay. Okay, so let me so okay. So we have the input. This is 10 volt. And here we have the output. Okay, let's say this is 5 ohm. And you want the voltage over here to be 5 volt. Okay, so this is a circuit which we have input of 10 volt and then output of 5 volt. 5 volt. Okay, so let's say we have a load of 5 ohm over here, and from here the current will be 1 ampere. So what we usually do is we put another resistor over here, which is 5 ohm. Okay, so we got the 5 volt over here if the current is 1 ampere. Okay, so this is the conventional way to change the output from the input from one voltage to another voltage. Okay, so we put something in between. Okay, so however, this part over here, okay, which is a resistor, there is some drawback to that, where here you will have heat dissipated due to the working of the resistor itself. Okay, so this is considered as loss. Okay, we don't want any heat. And for example, if you are charging your phone, you don't want your phone to be heated, right? Okay, so we don't want this. So we have to find another way to get the 5 volt from the 10 volt of input. Okay, so another way to do that, is by introducing a switch, okay, a semiconductor switch that we can control. Okay, so here we will have the same input. Okay, so here we will have the same input and then the same output. Okay, so this is V in. Okay, so here is V out. So let's say this is our node. Okay. Okay, so in order to control the output voltage from the given or fixed input voltage over here, we will use the semiconductor switch that we can control. Okay, so here we will control the on and off of this switch so that we can change the output voltage over here. Okay, okay, switch. Okay, so in order for us to control the switch, it has to be a semiconductor device, for example, a MOSFET. Okay, so here, if the switch is on, okay, as is on, so V node will equal to V in. And then if S is off or the circuit is open, we will have V node as equal to 0. Okay, so we will do this continuously on, off, on, off, on, off in a very rapid movement by controlling the switch that we have over here. And as for the output, very bad. Sorry about that. So for the output, okay, so this will be the time. And due to the on off of the switch, we will have the V node as this is during on. And then, okay, let me do it in different color. Okay, this is during on, so we'll have the V node as equal to V in. So this is V in. And then when the switch is off, we will have no output voltage or zero output voltage. Okay, so this will be continuously turn off and on and off and on. Okay, okay, so this is during switch on and here switch off. Okay, if we take average of this waveform, okay, assuming that the time for on and off is the same, the duration is the same, the average of this will be the output voltage that we will receive at the end, at the load. Okay, so this will be half of V in. So this is the voltage that we will receive as the output voltage, which is actually the average from the waveform due to the on and off of the circuit. Okay, so you actually have been introduced this in your electronics class. So the keyword here is duty cycle. Okay, have you heard about duty cycle before this? Okay, please reply me. Okay, you should be already familiar with the keyword duty cycle, okay, which you already being introduced in the electronics class. Tak pernah? Never? Okay, who did you take your electronics classes from with? Okay, duty cycle, you should be familiar with this. Okay, so for example, okay, so let's say just now, since the okay, just now, if you have, this is the previous one from the previous slide. If you have the duration for the on and off at the same rate, or T, say T1, T2, so T1, T2, if T1 is equal to T2, okay, so here you can say that this here 50% of the time switch is S is turned on. Okay, so this is also equal to duty cycle of 50%. Okay, so this 50% over here will determine the value of your output voltage or the average of this. Okay, so the average here is depending on the duty cycle that we have over here. Okay, so duty cycle is also for the definition. Where do I have the definition over here? Okay, the duty cycle is defined as the percentage of time of one cycle from one cycle when the switch is turned on. Okay, so let's see another example. Okay, so if I have another one, so T, so this is V node, and using the same circuit, but I change the duration of the on and off of the switch. So this time I will have the on time is very short compared to the off time. So this is one cycle, on and off. Okay, and then on and then off. Okay, so here we have two cycles. So here let's say only 10% of the time switches of the time. Switch is turned on. So here duty cycle is 10%. And if you see the average for this one, average of this waveform, okay, average of this waveform or the average, we usually take it from the area under the graph. Okay, average or this line over here is also can be find by calculating the area under the graph. Okay, so if you compare the area under the graph for this one and this one has uh, smaller value. So let's say average will be here. Okay. So this is the average. So as I said earlier, the average will give you the output voltage. Okay, so here the what I want to say is that by changing the rate of the switch is turned on and off, you can change the average value over here, which at the same time you are changing the output voltage. So this is what happened for this what do you call this uh, What do you call this one? DC chopper. Okay, so if you change the uh, duty cycle or the timing for the on and also the off, then you can change the average, which is translated to the output voltage for the circuit that we have in the previous slide. Okay, let me just save this one. So this will be the basic of the DC-DC converter that we will go through after this. Okay, so I will move on to the next slide. So maybe dah tak ingat. Okay, I think you don't remember, but I'm sure that this is one of the topic that you will discuss in the electronics class. Okay, so never mind. You can just go to the about the duty cycle in your notes if you still have it. Okay, so we can move on. Okay, so I will clear this one first. Okay, so this is the explanation of the basic DC-DC chopper. Okay, so here, this is how you calculate the duty cycle. Okay, you have the time where the switch is turned on and the time for one cycle, one off and one on. Okay, so you will have the duty cycle. Okay, so the average value of the output voltage is okay, V naught is equal to the duty cycle multiplied by the Vs. As you can see just now, D is, okay, sorry. Okay, as you can see just now, D is maybe, if you see the example, is 0.5 or 50% or 0.1, okay, 10%. Okay, so by using the switch, you can actually reduce down the output voltage.